Hello, this is Miss Prater. I'm going to do a short lesson on 7.05, area of a triangle. I do not have a whiteboard link for this because it only has, I think, 3 slides. So we have found area of a triangle in the past in our math classes. So I want to talk about that formula. So if you're thinking about, I do remember finding the area of a triangle, you may have used this formula, area equals 1/2 base times the height. So that would be anytime we know the base of the triangle. So let's say the base of this triangle is 5. Let's say it's inches. And the height of the triangle is, let's say, 10 inches. So the base and the height could look like this. You could also have a triangle where they gave you the base as 5. And then they drew in the height. So the height would have to be a perpendicular height to the base. And they told you, let's say that this height is 3. So your triangle doesn't have to necessarily be a right triangle. This example that I'm giving you, this triangle does look like it's a right triangle. But as long as you know the base and then the height, which is always perpendicular to the base, you could use this formula. So using this triangle, if we use the formula that we've used in the past, probably 7th, 8th grade is when we got introduced to this formula, we would just say area equals 1/2, base is 5, height is 10. Multiply all those numbers together, that's going to give me 25. And then when we do area, we take whatever unit we have and we square that area because we're really multiplying inches times inches, 5 inches times 10 inches, and then take half of that. So that's where we get the inches squared. So anytime we do area, we do our unit, whatever we're measuring in, squared. So what happens if we don't have the base and the height? So when we don't have the base and the height, we can use this other formula for area, and it's 1/2 A times B times the sine of angle C. So I'm going to go ahead and put capital letters on each vertice, and I'm just going to make up some measurements here. I do want to let me back up just a second. So when we name the vertices or the corners of the triangle, we do use capital letters for that. Let me go back and do a little background knowledge here for you. So we do use capital letters for the vertices. That's how we name the angle. So we can say this is angle A, this is angle B, this is angle C. The side that's opposite of angle A, so if we walk across the triangle from angle A, this would be side A. If we walk across the triangle from angle B, this would be side B, and we do use little letters for our sides, big letters for our angles, little letters for our sides, and then if we walk across from angle C, or opposite of angle C, that gives us side C. So if we were given, if we were not given the base and the height of our triangle, but we were given an angle and a side. So let's say they gave us that angle C was 40 degrees, and they gave us side A was 12. We'll do meters here. And side B, little b, was 7. So again, we don't know the base and the height. So 12 is the side of the triangle. It's not the height. So we could not find the area of this triangle using 1/2 base times the height. We could use this, I like to call it the trig. It's got trig in it because it's got sine in it. So let's take a look at this formula and how it would be used. So we would use area equals 1/2 A times B, sine of angle C. Now we're not going to always have A and B and C, so I'm going to show you this in the next example, but we'll make this one match the formula exactly just to kind of show you how it's used. So side A would be 12 because it's the side opposite of angle A. Side B would be 7 because it's the side opposite of angle B. And then we would do sine of angle C, and angle C was 40 degrees. And then we would put this into our calculator. So I think I have my calculator up. 1/2, 12, 7, sine of 40. So we would do 1/2. Don't know why that popped up. 1/2 times already forgotten. Where am I at? I'm right here. 12/7 sine of 40 times 12 times 7 times sine 40. Close parentheses. And that's going to give us 31.3 if we round to the nearest tenth. So the area of this whole triangle would be 31.3. And we're measuring in meters, so that would be meters squared. So if we were trying to paint, or we were trying to cover this area with grass, or plant a crop, this area inside this triangle, given the two sides and the angle, would be 31 meters squared. Now, if you'll notice, let's see if I can erase really quickly. What we have here is, if we kind of just forget about side A, side B, angle C, anytime you have two sides, and an angle included in between those two sides, you actually have the information needed to use this formula. So again, it's two sides, and then the angle has to be right in between. We like to use the word included in between. So on this last example, if we didn't label our triangle at all, and let's just say they told us this was 20 inches, this was 13 inches, and this angle that's included is, let's say, 72 degrees. As long as we have these two sides and the angle included, we can use this formula. So this would be 1/2 times 20 times 13 times sine of 72 degrees. So the A and the B, and then the angle C, if we labeled all of this, so if we labeled this angle C, because we do have to know angle C, if we went in and put our angles in, we just made sure the angle that we had was C, then this little side would be A, this little side would be B, and it really doesn't matter the order you're multiplying here. So again, just having the two sides and the angle included is what we need for this formula. And then we'll put this in. 1/2 20 30 sine of 70. 1/2 20 13. 1/2 times 20 times 13 times, make sure you hit sine first, 72. And hopefully we won't get an error because I just made these numbers up. 32.3. That's crazy that it was that close. 32.3 inches squared. All right, I think I do have one more slide. We'll let you practice one. So let's make this angle 65 degrees. And then we would have to know these two sides. So we'll make this 5 meters, and we'll make this 7.5 meters. So let's see if you can find the area. I'm going to do that on my calculator. Let y'all try to punch it in. So it's going to be 1/2. It doesn't matter whether the 5 or the 7.5 comes first. And then you'll have sine of 65 degrees. They may tell you how far to round. I'm just going to the 10th just because I'm deciding that on my own, but you'll just have to read your directions. All right, you punch this in your calculator if you want to stop the video for just a second. And come back and we'll see if you get the same answer. And I'm getting 6.99. And then I'm just going to round that up to 17. And then our unit was meters. So this is going to be meters squared.